All right. So we're going to define some vocabulary, and really our focus is to take this linear equation, represented as a table, as a set of ordered pairs, and then finally a graph. By the way, this is what you're going to be doing for homework tonight. So if you're stuck on homework tonight, find this, go to your Edline page, go to today's date on your calendar, play this video, and you'll have this much time in the comforts of your home. I know everyone's thrilled about that. So let's fill in the blank. A blank is a set of ordered pairs. Who thinks they know that? Who can remind us what is just any set of ordered pairs? Ooh, thank you, ma'am. A relation. I wish I could say your name and throw you a shout out. A relation. I'm going to put a little cloud around it. Is a set of ordered pairs. It's like any generic ordered pair. It doesn't have to follow any rules. Just has to have more than one point. It is a relation. Here's an example of a relation. We took a quiz, we took a test, we did some practice that says you can take any set of ordered pairs. Just to throw this out there, how many points would this be on a graph? Somebody, anybody? How many points would this represent on a graph? Thank you, sir. In the back, holding up 4. 4. Here's a point, here's a point, here's a point, here's a point. So we can take this list of ordered pairs. Let me be completely accurate and put brackets to show that it is a set. Please do that as well. And I can take and show this exact same information with a mapping, the same information in a table, and I can list the domain as well as the range. There are some rules, though, for the mapping. Who can remind us how the X's have to be written in the mapping, and actually when we list our domain and range? Yes, ma'am. Ooh, I heard that. Awesome. Least to greatest in order. So I'm going to take, I know you don't need this, I'm just going to put an X over all of my X values. And I'm going to find the smallest one, 2. That's going to be the first thing in my mapping. And then 3, and then 4, and then 7. Because order matters. I'm going to do the same thing for my Y's. Who can give me my Y's?
5, 6, 8, 1.
In order. Can you do it again in order?
1, 5, 6, 8.
Perfect. 1, 5, 6, 8. This is why all of our lines go crazy. Because when I show this ordered pair, it's not going to go straight across, because 2 is related to 6. 3 is related to 5. Lines cross, that's okay. 4 is related to 8. 7 is related to 1. So your lines should not all go straight across in your mapping. They might crisscross, and that's okay. Okay, for our table, tables are easy. We'll show this ordered pair 3, 5 by putting a 3 here, since 3 is our X value. 5 goes here. These, by the way, they do represent one ordered pair, so order doesn't matter as much here with your table. 2, 6, 4, 8, 7, 1. Domain. That's a vocabulary word for us. Who can tell us which values, our X or our Y values, go with our domain? Yes? The X values, perfect. So I'm going to cheat. I'm going to come over here to my mapping and just write down the x values. 2, 3, 4, 7. In order and no repeats. It could repeat here, but when you list your domain, you're only going to list it once. Who can give us our range? If our domain is 2, 3, 4, 7, then our range must be
1, 5, 6, 8.
all of our y's. And I heard someone say it with me, guys, everybody. Here's your chance to be on the World Wide Web. 1,
5, 6,
5, thank you. 6, 8. Whew. We're just warming up. It's our first day back from 2 weeks. So all right, so this is kind of, this is kind of our, in a nutshell, review of relations. Any set of ordered pairs. Okay, now we're going to get in the nitty-gritty and talk about graphing linear equations.
Actually, I'll turn this a little bit and make sure that we can see everything.
Okay, so now we're going to graph some linear equations. And you know what, I think I am going to
Yeah,
move
you
it up.
want to move it over here.